Continuously variable transmission. A continuously variable transmission CVT is an automatic transmission that can change seamlessly through a continuous range of gear ratios. This contrasts with other transmissions that provide a limited number of gear ratios in fixed steps. The flexibility of a CVT with suitable control may allow the engine to operate at a constant RPM while the vehicle moves at varying speeds. CVT are used in automobiles, tractors, motor scooters, snowmobiles, bicycles, and earth-moving equipment. The most common type of CVT uses two pulleys connected by a belt or chain, however. Types: pulley-based. The most common type of CVT uses a V-belt which runs between two variable diameter pulleys. The pulleys consist of two cone-shaped halves that move together and apart. The V-belt runs between these two halves, so the effective diameter of the pulley is dependent on the distance between the two halves of the pulley. The V-shaped cross-section of the belt causes it to ride higher on one pulley and lower on the other. Therefore, the gear ratio is adjusted by moving the two sheaves of one pulley closer together, and the two sheaves of the radial thickness of the belt is a compromise between the maximum gear ratio and torque. Steel-reinforced V-belts are sufficient for low-mass, low-torque applications like utility vehicles and snowmobiles, but higher mass and torque applications such as automobiles require a chain. Each element of the chain must have conical sides that fit the pulley when the belt is running on the outermost radius. As the chain moves into the pulleys, the contact area gets smaller. As the contact area is a belt-driven design offers approximately 88% efficiency, which, while lower than that of a manual transmission, can be offset by enabling the engine to run at its most efficient RPM regardless of the vehicle's speed. When power is more important than economy, the ratio of the CVT can be changed to allow the engine to turn at the RPM at which it produces the greatest power. In a chain-based CVT, numerous chain elements are arranged along multiple steel bands layered over one another, each of which is thin enough to easily bend. Toroidal Cvt, as used on the Nissan Cedric 34, consist of a series of discs and rollers. The discs can be pictured as two almost conical parts arranged point to point, with the sides dished such that the two parts could fit into the central hole of a torus. One disc is the input, and the other is the output. Between the discs are rollers, which vary the ratio and transfer power from one side to the other. When the rollers' axes are perpendicular to the axis of the discs. Ratcheting. A ratcheting CVT uses a series of one-way clutches or ratchets that rectify and some only forward motion. The on-off characteristics of a typical ratchet means that many of these designs are not continuous in operation, i.e. technically not a CVT. Ratcheting CVT can transfer substantial torque because their static friction actually increases relative to torque throughput, so slippage is impossible in properly designed systems. Efficiency is generally high because most of the dynamic friction is caused by very slight transitional clutch speed changes. The drawback to ratcheting CVT is the vibration caused by the successive transition in speed required to accelerate the element, which must supplant the previously operating and decelerating. The design principle dates back to before the 1930s, with the original design intended to convert rotary motion to oscillating motion and back to rotary motion using roller clutches. Hydrostatic/hydraulic. Electric. Cone. A cone CVT varies the drive ratio by moving a wheel or belt along the axis of one or more conical rollers. The simplest type of cone CVT, the single cone version, uses a wheel that moves along the slope of the cone, creating variation between the narrow and wide diameters of the cone. Some cone CVT designs use two rollers. In 1903, William Evans and Paul Knopf applied for a patent On a continuously variable transmission using two parallel conical rollers pointing in opposite directions and connected by belts that could be slid along the cones to vary the transmission ratio. The Evans variable speed countershaft, produced in the 1920s, is simpler. The two rollers are arranged with a small constant width gap between them, and the position of a epicyclic. In an epicyclic CVT, also called a planetary CVT, the gear ratio is shifted by tilting the axis of spherical rollers to provide different contact radii, which in turn drive input and output discs. Other types, friction disc transmissions, were used in several tractors and small locomotives built in the early 20th century. Infinitely variable transmissions. Some CVT can also function as an infinitely variable transmission IVT, which offers an infinite range of low gears, e.g., moving a vehicle forward at an infinitely slow speed. In an epicyclic IVT, infinitely low drive ratios are produced when the output shaft rotation speed is equal to the difference between two other speeds within the CVT. In this situation, the CVT is functioning as a regulator of the rotation speed of any one of the three rotators of the planetary gear system. Origins. In 1879, Milton Reeves invented a CVT, then called a variable speed transmission, for use in sawmilling. In 1879, Reeves began fitting this transmission to his cars, and the Reeves CVT was also used by several other manufacturers. The 1911 Zenith Gradua 6HV motorcycle used a pulley-based Gradua CVT. A year later, the Rudge Whitworth multigear was released with a similar but improved CVT. Other early cars to use a CVT were the 1913–1923 David Small three-wheeled cyclocars built in Spain, the 1923 Clino built in the UK, and the 1926 Constantinesco saloon built in the UK. Applications. Automobiles. The first mass production car to use a CVT was the 1958 DAF 600 from the Netherlands. Its variamatic transmission was used in several vehicles built by DAF and Volvo until the 1980s. The 1987 second-generation Ford Fiesta and first-generation Fiat Uno became the first cars to be equipped with steel-belted CVT, as opposed to the less robust rubber-belted DAF design. The Multitronic transmission was 1999 Nissan Cedric 34 used a toroidal CVT, unlike the pulley-based designs used by other manufacturers marketed as the Nissan X-Trade, which incorporated a torque converter. Nissan then switched from toroidal to pulley-based CVT in 2003. The version of the CVT used with the VQ35D engine in the fourth-generation Nissan Altima is claimed to be capable of transmitting higher torque loads than other belt CVT. The 2019 Toyota racing cars. In the United States, Formula 500 open-wheel racing cars have used CVT since the early 1970s. CVT were prohibited from Formula One in 1994 along with several other electronic systems and driving aids due to concerns over escalating research and development costs and maintaining a specific level of driver involvement with the vehicles. Small vehicles. Many small vehicles such as snowmobiles, golf carts, and motor scooters use CVT, typically of the pulley variety. CVT in these vehicles often use a rubber belt with a non-stretching fixed circumference manufactured using various highly durable and flexible materials, due to the mechanical simplicity and ease of use outweighing their comparative inefficiency. Farm and earth-moving equipment. Combine harvesters used variable belt drives as early as the 1950s. Many small tractors and self-propelled mowers for home and garden use simple rubber belt CVT. Hydrostatic Cvt are more common on the larger units. Hydrostatic Cvt are used in small to medium-sized agricultural and earth-moving equipment. Since the engines in these machines are typically run at constant power output to provide hydraulic power or to power machinery, losses in mechanical efficiency are offset by enhanced operational efficiency. 1965 wheel horse 875 and 1075 garden tractors were the first such vehicles to be fitted with a hydrostatic CVT. The design used a variable displacement swash plate pump and fixed displacement gear type hydraulic motor combined into a single compact package. Power generation systems. CVT have been used in aircraft electrical power generation systems since the 1950s. CVT with flywheels are used as a speed governor between an engine, e.g., a wind turbine, and the electric generator. When the engine is producing sufficient power, the generator is connected directly to the CVT, which serves to regulate the engine's speed. When the power output is too low, the generator is disconnected and the energy is stored in the flywheel. It is only when the speed. Other uses. Some drill presses and milling machines contain a simple belt drive CVT system to control the speed of the chuck, including the jet models J5816 and J5818. In this system, the effective diameter of only the output shaft pulleys is continuously variable. The input pulley connected to the motor is usually fixed in diameter or sometimes with discrete steps to allow a selection of speed ranges. The operator adjusts the winches and hoists are also an application of CVT, especially for those adapting the transmission ratio to the resistant torque. Bicycles with CVT gearing have had limited commercial success, with one example providing a range of gearing equivalent to an 8-speed shifter. The bicycle's short gearing assisted when cycling uphill, but the CVT was noted to significantly increase the weight of the bicycle.